Hello, everyone. My name is Dusko Vukmanovic, and I'm the product manager, and I will present you today OCI Service Mesh. So first of all, we will talk about why we need Service Mesh at all, and then how we built our OCI Service Mesh. What are the benefits that you can get from while using Service Mesh? What is the architecture? And then I will show the demo of OCI Service Mesh features, and then there will be closing remarks. So everything starts with why customers. So is Oracle. You're all using like Kubernetes containers, microservice architecture, as a tools in order to be agile, in order to react quickly on their customers' needs, and in order to respond to the competitive threats. So this is why customers in general today using those technologies, and they build, and essentially they're building cloud native applications. Now, in the center of the cloud native applications are services, and now remember, now you have different teams who are using different frameworks, different languages in order to build those services, and then the way how you connect those services is actually how you deliver your cloud native application. But then the goal is, and each service has like a business requirement and capabilities, but also there is also a set of infrastructure requirements like a security, connectivity, and monitoring, which are needed for each of those services. So the question is like how we can ensure this, for the all of our services that we are using, how we can have this on scale and not to build this each time for each service. So, well, you can use the libraries of your language that you are using, and then you can build those features, those infrastructure requirements. But it's very hard to have to use consistent pattern across those different teams and different languages in order to solve the same issues all the time. So and again, for some things, it's not about just to build things. You have to maintain things. And very specific example is security. Even if you are using libraries to create secure communication between your services, you have to create those certificates, and then you have to rotate certificates. So it's kind of bring a burden on the application teams. Now, what Service Mesh actually this is another layer. You can think of Service Mesh as another infrastructure layer, which bring those capabilities that you can use by configuring this layer and without any change to your application. So without Service Mesh, you can think of like 3 layers, like infrastructure, and then you have orchestration, which is Kubernetes, and then you have application. Now, between application and Kubernetes, we are putting Service Mesh layer, which then you can use without any change to your application. So what actually, what brings you Service Mesh? It's by the way, it's a free and managed service by Oracle. But from my perspective, it really brings 2 major things. One is increased developer productivity. But the way how we increase this productivity is because developers now can focus on building business requirements and not coding the infrastructure requirements. So Mesh gives you security, end-to-end visibility, and options that you can connect your microservices dynamically. So this is one side. The second side is like improve operational efficiency, because when the team creates a new service, when they deploy a new service, this is not enough. You have to expose this service to your external clients. But then, there is, Kubernetes is pretty complex. There is Kubernetes network. So this is, again, another obstacle for the application team. And without Service Mesh, essentially, they have to cut the ticket to networking team or to operations team. And then really you are losing a little bit of this agility that we talked about at the beginning. But with Mesh, now you have a central place where application team can define how services are able to communicate with each other. So, and again, it's very easy. So application team now have a full control of their application and how services are able to communicate with each other. So this is how we built our OCI service mesh. On the left side is a diagram. So you see this proxy component that we inject in the pods. Pods are where your workload is. And now once we have this component in the architecture, now we are able to intercept any traffic that goes in, goes out from your services. And this is how we control how you control your application. Now you are using control plane, and you can think about control plane as a OCI console. You go there, you configure service mesh, and then push this configuration to proxies, and now you are changing the behavior of your application. On the right side, you can see the features that we are supports now, and they are ordered by importance that I have got based on discussion with internal and external teams. So number one, why would you service mesh is about security, how you ensure the access control and secure connection, between services. Next thing is how you monitor your application, not just by service, but like end to end. And you see here that for the logging, we have integration with OCI logging, and we produce a lot of metrics, but in order to collect those metrics, you need to use Prometheus. And for the connectivity, we provide service-to-service traffic control, but also we provide like ingress traffic control. And this is how you control how you will expose your application to the external clients. Currently supported platform is OKE, and very soon we will support also other flavors of OKE, and then you can also see communications protocols that we are supporting today. So, who can benefit from using service mesh? Well, of course, in general, if you have more services, this is just a pure economy of scale. You can have more benefits, but the point here is like, because again, it's a free and managed service. And on the other hand, today security is not an option, but it's more like requirements for almost any business. So because it's free and managed, and it's and then security is very strong requirement. Even if you are a smaller organization, you can have a benefit of using OCI service mesh. It's not just for the for the big enterprises. Now let me go a little bit one step down and into giving you more details about three key capabilities that service mesh brings to you. First is security. So it's enabled by default. In the moment when you enable the mesh, you have secure service-to-service communication. The way how you set up this while defining the mesh, you should define your certificate authority, your private key, and then we will use them to create leaf certificates, and we will rotate them. So it's a really it's enabled in the moment when you have the mesh. From the observability perspective, we produce a huge number of different metrics like request rate, like latency, different HTTP requests. It's upstream and downstream, and now you just have to collect them using Prometheus. Now, again, this is again example where is a huge benefit of using service mesh, because you have a different teams who are building those different services, and now it's very hard for them to have unique set of metrics. Now, even if they're using, let's say, one framework, they, in order to get those metrics, you will, depends on the framework, but you will have to some extent, instrument the code. But then, when you have different teams, more, even if you have some metrics with the same meanings, or most likely they will have a different name. So it's a hard, it's not easy to have like end-to-end visibility without mesh. And then for the OCI logging, we are providing additional log. So we have integration with OCI logging. So all those requests that goes out from your services, we log this, and then we call this access log, and you can get them in OCI logging, and then you can. It's really helpful for the troubleshooting. Very very quickly, you can find any response code like 503, 404, and then you can use them for further analysis. And then you can also manage the traffic. So you can with service mesh you have an easier way to introduce a new version. For example, you can have a multiple version of your service in parallel, and then you can decide how percentage of that traffic you want to give to this new version. And then when you gain confidence, you can switch more traffic, but if anytime if something goes wrong, you can switch easily back. So it's kind of canary deployment. You can also use A/B testing. And then for exposing your application to the external clients, you have a ingress gateway where you can configure either a host-based name or path-based name. You can you can expose them to external clients, and then you have a full control of all traffic that goes into your application. Now, let me just now talk a little bit about the mesh resources and what does it mean to enable the mesh for your application. So I have this very simple basic Kubernetes application with two services. Like service, you can think of service A as a UI, service B as a backend service. Now, and then using pure Kubernetes objects, we are exposing this application through Kubernetes service type of load balancer to the external clients. Please have in mind that the lines here with the arrows are just a logical flow, but the real communication is always happening among the pods. And now you can also notice that even Kubernetes itself offers you a higher level of abstraction, because otherwise, you don't know, when you are building your application, you are not aware, what is the IP of your other pod. So Kubernetes offers you this abstraction so that you can easily create your application. Now the service mesh offers you another level of option that how you can manage your application. So on this diagram here, you can see the green parts. So the green parts are mesh resources that you will create. And please also notice the blue parts are the Kubernetes application from the beginning, and we didn't touch this application. So it still works as is. Now what you do now, all those mesh resources like virtual service deployment are virtual. So there is no running pods behind them. There is no any running resources on your Kubernetes behind them. It's a virtual, but you are using them. You are using features. For example, you are using feature from the virtual service route table, and then you can specify how your services will communicate. So in this case, for example, when you have a line of code in your service A, when you call service B, actually we will intercept this call, and then we will see in the service B routing table how much percentage we should give to version B2 versus B1, and then this is how the pods will communicate. And again, always the real communication is happening among the pods. Now you also see here the picture ingress gateway. This is how you expose your application, and have in mind that there is no communication unless you explicitly specify access policy. So in the moment when you enable the mesh, services are not allowed to talk to each other unless you specify ingress gateway can talk to service A can talk to service B, and then service B can talk to service A. So in that way, you are secure that external clients are not able to call any of your any other service, but they only can call ingress gateway, and from there you have a full control. Now, the next thing that I want to show you also just have in mind that there is like two ways how you can work with OCI service mesh. So there's two approaches. One is with kubectl. And then, so if you are using kubectl to manage your Kubernetes for day-to-day operations, then you can continue to use kubectl to manage the mesh. And in front of you, I just have an example of few mesh resources that you can that you will create, and then just run with kubectl -f apply, and then this is how you will create them. The source for this you will get through documentation. You go there, you just copy paste template and just fill in your details, and you are done. It's pretty quickly. And this is one approach. The second approach is you can use OCI API. And when I say OCI API, you can use Console, Terraform, SDKs, CLI. Again, both options, both approaches are fine, but just it's more about like what is your preferred way to work with the mesh. And I also showed you this kubectl experience because in the demo that I will show you, I will use this approach. And now I will do demo service mesh features for you.
Hello there. In this demo, I'm going to show you how you can use a free and managed service, the Oracle Cloud Infrastructure Service Mesh, to secure, monitor, and dynamically connect your microservices without making changes to your app. We support two experiences while working with the Service Mesh. The first is to use OCI console and then OCI APIs, and the second is to use kubectl. Let me show you quickly our pet rescue sample app. It comprises 4 microservices, and you will notice that the Pets microservice has 2 versions deployed. The second version is connected to the Pet Details microservice, and it will return more information than version 1. I already have a cluster running with an application that is mesh enabled. This is the application, and you can see the different responses from the Pet service in versions 1 and 2. To enable the mesh, you have to create mesh virtual resources that will be used to manage your application, a kind of abstraction layer. I'll quickly go through the mesh resources now. So I'm on the mesh page. Here you can see what service mesh will use as a certificate authority for the mutual TLS connection between microservices. Minimum MTLS specifies the level of MTLS authentication required for all virtual services is inside the mesh. Permissive means that we accept both TLS and plain TCP communication. Here you can see the virtual services, which mirrors the microservices that you manage in your application. Each virtual service can have multiple versions, and each version has its own virtual deployment that is tied to a group of pods that represent that microservice version. The routing table will be used to control traffic. And I'll show you now the traffic between the two versions that is in split in a 50-50 ratio. Here are the access policies where you define how microservices can communicate. You can see how ingress traffic is only allowed to the UI service. And then this microservice talk to other microservices. This row specifies that all microservices can talk to UI microservice. That was a quick introduction to OCI Service Mesh, and now I can show you the advantage of having OCI Service Mesh enabled. I'll keep working on security. I have just showed you the access policies. To enable the Zero Trust architecture, the OCI Service Mesh security feature supports mutual TLS, MTLS. OCI Service Mesh will automatically encrypt and authenticate the communication between your microservices, and it will do so without requiring any step on your part. It's turned on by default, and since it is enabled by default, I can only test if MTLS works. Let me demonstrate how microservices are now communicating using MTLS. I'm using the OpenSSL utility on an OpenSSL test pod, and I'm using OpenSSL command to connect to the UI microservice, and I want to create an MTLS connection. This command cannot be successful because the client that is trying to connect to the UI microservice does not have a certificate. He can only go through Ingress Gateway with the proper routing rules because we have permissive mode. Here you can see what certificate is being requested from the client. And here you can see what certificate is the UI microservice is presenting. In this example, it has a role of the server side. Here is the issuer of the certificate with a virtual service ID as a subject so that we can know who is on the other side. Now let's check the application's overall health. For that, I'm going to check the Grafana dashboard. OCI Service Mesh proxies automatically emit telemetry data such as latency, HTTP errors, and requests from all microservices in the mesh. It provides integration with Prometheus so that you can create dashboards and alarms based on the collected data. Here you can see that UI microservice has some latency, and here you can see that the pets v2 version causes the overall application's poor performance. Once you know what the issue is, you can fix it and deploy the update. This is what I'm going to do now. Before that, just you can see how the traffic is splitted 50-50. I'm deploying a fix for the version v2, and let's also split the traffic so that only 10% goes to the new version until we gain confidence in it. We can then, over time, slowly move traffic to the new version v2. This is how we provide advanced deployment option. And that was the YAML file that I'm using for traffic configuration. This is the kubectl experience I mentioned earlier. Let's see how the application health looks now. The v2 is looking good, and traffic is trending towards 90-10 split, and we can see that UI is now fine too. Now we will see how to troubleshoot issues with the help of logs that proxies generate using OCI logging as a central place for analyzing logs. I can just quickly check what logs information provides microservice pets version 1. And here you can see that we depend on the apps developers to add proper level of logging. There is not much here. Before I go to the logging, let me scale my microservice to 0 so that we introduce 503 error. Let's see if app is still working. No, it does not. Now I'm going to the OCI logging to see what is going on. I can look at log messages, but it will be quicker if I search the logs for an 50x errors. I'm using the logging feature to store my search and quickly find what could be wrong. I'm looking for response code 50x. This is line coming from the proxy. And we can see what service was called when response code 503 happened. This means microservices in our case is not available. Let me fix the app. All right, it works now. And I'm back on the mesh details page. This concludes the demo where I showed you how you can secure, observe, and connect microservices without any change in the application itself with the help of OCI Service Mesh.
The way how the OCI Service Mesh simplify development is by providing those capabilities, security, observability, and connectivity, and this is how increase developer productivity. And other things of operations is about efficiency. So it provides you a central place where application team can manage how services are able to communicate with each other. So here are the list of additional resources that you can use for to find out more. But now when we know each other, you can always connect me if you need more, if you have more questions about OCI Service Mesh. Thank you very much for attending this session.